We have already discussed in detail global stability analysis. Segment level stability analysis extends the concept to the segment level. So rather than asking if the entire market segmentation solution is stable, we want to find out if one specific segment occurs over and over again over repeated calculations. But why do we need to assess stability at the segment level? Because most of the time, managers are only interested to identify one single attractive market segment. They cannot cater to a large number of segments simultaneously. Global stability analysis averages stability across all segments. So, using global stability, a segmentation solution with many reasonably stable segments would look better than a segmentation solution where one segment is highly stable while the others are very unstable. But this second solution is usually more valuable for a manager who is looking for one optimal market segment to target. To find this one optimal target segment, we need to assess stability at segment level. There are two kinds of stability at segment level: segment level stability within solutions and segment level stability across solutions. Segment level stability within solutions assesses whether the specific market segment of interest reoccurs across repeated calculations if the same number of market segments is extracted. So, if you run 50 repeated calculations and extract 5 segments each time, we can calculate segment level stability within solutions. Segment level stability across solutions assesses whether the specific market segment of interest reoccurs across repeated calculations with a different number of market segments is extracted. So if you run calculations to extract 4 segments, 5 segments, and so on until, say, 10 segments, we can calculate segment level stability across these solutions. Optimally, the market segment we are interested in occurs already in the 4-segment solution and remains virtually unchanged until the 10-segment solution. How do we calculate segment level stability within solutions? First, we compute a segmentation solution with k segments for our empirical dataset. Any extraction method, distance-based or model-based, can be used. Second, we need to draw a number of samples from the consumer dataset. Each of those samples is slightly different. We can do this easily using bootstrapping. The reason for using a number of slightly different datasets is the same as it was for global stability analysis. Because our sample is not a perfect reflection of the actual consumers, we add a bit of noise to make the results of the analysis less dependent on the exact nature of our sample. Based on our experience, drawing about 100 bootstrap sample works well. Next, we extract k market segments from each one of those bootstrap samples. Then we calculate, for each bootstrap sample, the maximum Jacquard coefficient between a market segment extracted from the empirical dataset and all market segments extracted for the bootstrap sample. The Jacquard coefficient measures the overlap between 2 segments. This is done by calculating how many consumers are in both segments and dividing it by the total number of consumers in both segments. We then plot the maximum Jacquard coefficients for all bootstrap samples across all market segments and inspect those plots. The plots provide insight into how stable each individual market segment is for this dataset. Based on this plot, we can choose which segments to inspect further. Let's have a look at one of those plots. The plot is a parallel box plot. It shows the distribution of the Jacquard coefficient over 100 bootstrap samples for each segment. The horizontal line in the middle of the box is the median value, and at least 50% of all the Jacquard coefficients lie within the box. What we want to see is a high median value and a narrow box, because this tells us that we can consistently extract this market segment across replications. In the plot we see here, the highest stability levels are obtained for segments 1, 5, and 6. These are candidates for target segments and should be inspected in more detail. Segment 3 emerges as a very unstable segment and can be excluded from subsequent analysis. How do we calculate segment-level stability across solutions? First, we compute segmentation solutions with different number of segments for the empirical dataset. Any segmentation method, distance-based or model-based, can be used. Second, segments across solutions are matched using a renumbering algorithm. We need to do this because each repeated calculation names segments differently, and we need to figure out which of them are similar. This can be done easily in R. Third, for each market segment, the segment stability index across solutions is calculated. This index is high if a segment recruits many members from the same segment from the solution with fewer segments. The index is low if the segment recruits members, especially an equal number of members, from many different segments in the solution with fewer segments. We then plot the development of each segment across segmentation solutions with different numbers of segments and inspect those plots. This plot provides insights into the stability of each individual market segment across segmentation solutions with different numbers of segments. Naturally existing segments in the dataset emerge as stable segments. Artificially created segments emerge and disappear across the segmentation solutions. Let's have a look at one of those plots. Each column in the plot represents the market segmentation solution with a specific number of segments. The number of segments extracted increases from left to right. The column on the far left represents the segmentation solution with 3 segments. The column on the far right represents the segmentation solution with 8 segments. The lines between segments indicate movements of segment members between segments. Thick lines between 2 segments indicate that many segment members are retained, despite the number of segments increasing. Green color is used here to indicate high stability. Segments which have many lines coming in from the left and which branch into many lines to the right suffer from changing segment membership across calculations with different numbers of segments. Such segments are more likely to be artificially created during the segmentation process. In this plot, we see that segment 1 is the most stable across solutions. Segment 3 in the 6-segment solution emerges as an entirely new segment in this solution and immediately disappears again. It is depicted as a grayed node in the plot. If you remember, this was the very same segment which displayed low segment level stability within solutions in the previous plot we discussed. So, stability analysis in general provides critical insight into the data structure before segments are extracted. As such, it prevents managers and data analysts involved in market segmentation analysis from extracting market segments blindly. This in turn substantially reduces the risk of arriving at a random market segmentation solution. Segment level stability digs into more detail than global stability analysis. It allows us to identify stable segments. Such stable segments are excellent candidates for further consideration as we try to find the one final market segment to a target.